Welcome back. Let us continue our discussion on differential amplifiers. Here, I would like to talk about one mathematical aspect of the signals. So, as we are familiar with the amplifier, an amplifier is a device which increases the amplitude of the input signal. So, in a differential amplifier, the input is provided as a difference of two inputs. So many of you might be wondering that how a general signal can be provided as an input to the differential amplifier, because let us suppose this is a differential amplifier and I want to give this general signal as an input, but the differential amplifier has two inputs. So one possibility might be this, that we can provide this signal at one input and we can provide no input at the other input, or other input can be grounded. But again there will be some issues of noise. If there will be any noise and at ground, uh, there the noise might not corrupt the ground, because there is no voltage, because a voltage is more prone to noise. So there is a possibility of noise whenever we provide only one input. But in general, this is a possibility that we can provide only one input. But again there will be issue of noise. So how can we provide the same signal, which is an AC signal, to the input of the differential amplifier as a difference of two input signals? As we know, the input of the differential amplifier is the difference of two signals. Here let us suppose I want to give this signal as an input, a signal A sin omega t. A is the maximum amplitude in the positive side and minus A is the maximum amplitude in the negative side. So this is one method that I am telling you. We can use this algebraic equation, A equal to A by 2 minus A by 2. So if we look at this algebraic equation, then this and this A by 2 and minus A by 2 are the additive inverse. This A by 2 and we are subtracting two additive inverse, and we are getting the original signal. Similarly, if I use A by 2 sin omega t signal, here the geometry of the signal comes in the picture. So A by 2 sin omega t and minus A by 2 sin omega t. So this is a minus A by 2 sin omega t, and we subtract these signals. So this is A by 2 sin omega t and minus A by 2 sin omega t, and A by 2 minus A by 2. So let us cross check this thing. A by 2 sin omega t, and at 90 degree this must be minus A by 2. So at 90 degree this is minus A by 2. So now by the geometry of this signal, I can represent this signal as this, because this is negative and negative sign, and we know that if something is like this, V naught equal to minus A V I. So this is the amplification is there, but the negative sign is indicating inversion. So the 180 degree phase shift, or we can say, so inversion or 180 degree phase shift. Here this signal will be 180 degree phase shifted, and negative sign will be converted into the positive sign. Now if we add these two signals, because this is same and this is equivalent to this negative of this signal is equivalent to positive of this signal. These both are the same thing. just like in algebra, if you want to understand x equal to minus of minus x. So if we add these two signals, and geometrically if we add these two signals here, and at the all the timings if we try to add these two signals, then we will get this signal, this original signal. So this is how we can apply the input. And it is not necessary that we must have this amplitude is just half for one signal, half and another for half. We can have these kind of combination also. Here the flexibility is this, that we can have one signal and other signal is only 180-degree phase shifted. Other signal is only 180-degree phase shifted, and we can apply the input like this. One signal is xt, which is let us suppose a by 2 sine omega t, and another signal can go from here, and all we need to do, we need to provide a network which provide a 180-degree phase shift, and just 180-degree phase shift, no change in gain. So I mean a must not change. So a network which provide a unity gain and 180-degree phase shift. So this signal is minus xt and this is the xt. So this is how we can provide the input here in this case, and in this case we need to provide the separate signals because the amplitude are different. So this is the basic mathematics of the signal. So again I am concluding this complete part. To provide a signal as a input to the difference or differential amplifier, we have two options. Either we can provide one input as a grounded and other input as a input signal, and the other option is this mathematical analysis. So in the first option, again the noise will be issue, because whatever input is provided, if there is any noise there, then the noise is getting amplified. And the other side you have not provided any signal. So if the noise is may corrupt the ground level, but it won't affect that much in compared to the voltage applied, because applied voltage is more susceptible to the noise compared to the a grounded connection. So I hope this small concept is clear. So in the next session I will deal with the next topic.